Today on My Climate Journey, our guest is Dr. Sarah Kapnick, Chief Scientist at NOAA. NOAA is the National Oceanic and Atmospheric Administration, and it's an agency of the U.S. federal government within the U.S. Department of Commerce. NOAA's mission is, quote, to understand and predict changes in climate, weather, ocean, and coasts, to share that knowledge and information with others, and to conserve and manage coastal and marine ecosystems and resources. Dr. Kapnick took on the role of Chief Scientist in 2022 after a year's stint in the private sector as Senior Climate Scientist and Sustainability Strategist at J.P. Morgan Chase. Prior to that, she was a physical scientist and Deputy Division Leader at NOAA's Geophysical Fluid Dynamics Laboratory, or GFDL, where her work spanned seasonal climate prediction, mountain snowpack, extreme storms, water security, and other climate impacts. She received a PhD in Atmospheric and Oceanic Sciences with a certificate in Leaders in Sustainability from UCLA and an AB in Mathematics with a certificate in Finance from Princeton University. And in between those academic stints, she spent 2 years as an investment banking analyst with Goldman Sachs. As her bio attests, Dr. Kapnick brings a unique blend of science and finance into her role at NOAA. We hit on a number of topics, including an introduction of NOAA and its various departments, such as the National Weather Service and the National Ocean Service. We spend a lot of time talking about resiliency and adaptation, and where we as a country and a society are in the recognition of what is likely to be a significant area of investment and focus for the remainder of the 21st century. Dr. Kapnick reminds us that just about everything we know was built and created with the assumption of a stable climate. And that assumption, unfortunately, is no longer valid. We talk about the role of NOAA in helping stakeholders plan for a less stable future. And we talk about what is actually going on with our oceans today and how that impacts extreme weather and our atmosphere. Lastly, she also shares more about NOAA's efforts in supporting communities in need, as well as in supporting innovation around resiliency. But before we start, I'm Cody Sims.
I'm Yin Lu.
And I'm Jason Jacobs. And welcome to My Climate Journey.
This show is a growing body of knowledge focused on climate change and potential solutions.
In this podcast, we traverse disciplines, industries, and opinions to better understand and make sense of the formidable problem of climate change and all the ways people like you and I can help. Dr. Sarah Kapnick, welcome to the show.
Thank you for having me.
All right, let's just jump right into it. What is NOAA?
NOAA is the National Oceanic and Atmospheric Administration, and it's an agency that sits under the U.S. Department of Commerce.
In doing my very in-depth research on, I believe, Wikipedia, saw a fun fact that it sits under the Department of Commerce because of some feud between Richard Nixon and the at the time Secretary of the Interior over Vietnam War policy. And Nixon said, "You don't get NOAA, I'm going to give it over here to Commerce." Is that true?
That is the lore. At the time, they thought that it should sit under Interior because there's other aspects of fish and wildlife on land that we have with managing fisheries in the ocean and the Great Lakes. But actually, I would say now with everything that NOAA does, it makes complete sense that we're under Department of Commerce.
We are going to get to all of that because you have a fascinating background with a blend of atmospheric and oceanic science, as well as practical finance, and bringing the two together, which I think is interesting that NOAA actually sits under the Department of Commerce, because so much of what you're doing, I'm guessing, is predicting impacts of the world from a climate perspective, a weather perspective. And a lot of those predictions go to feed what are we going to do about it from a financial perspective. Would that be an accurate way to think about many of the consumers of your data?
That's the consumers of that data from NOAA. And that's also my entire reason for my career has been trying to be at that intersection to make sure that we're getting science into the hands of decision makers for the decisions that need to be made around weather, climate, fisheries, the ocean.
And NOAA it's a big agency, like 12,000 people, somewhere around there, and looks like almost 7,000 scientists and engineers. That's a lot of horsepower.
We're half of the Department of Commerce.
Really? Wow. When I think of NOAA, I think of the National Weather Service. I think of the National Ocean Service. Are those the big pieces in NOAA, or are there many other things as well that I should be thinking about?
So we have 6 line offices total. And so you're thinking National Weather Service, where you get your weather forecasts from. National Ocean Service, that does the information of where the sea bottom is, the bathymetry maps. Anyone who's a sailor along the coast, they often have our maps that have the little NOAA seal in the corner looking at the coastline. So we produce that. But there's also all the information of how is sea level rise changing or varying in the tides. We also have National Marine Fisheries Service, which both does research on fisheries, but also is the regulator of fisheries. We have one of the most sustainable fisheries in the world because of the management practices that they have in place. There's also the Office of Marine and Aviation Operations, which is one of the 8 uniform services. And those are the brave men and women that fly directly into hurricanes to be able to take the measurements we need of hurricanes to understand how they're developing, how they are changing, and it improves our forecasts. They also fly into atmospheric rivers and pollution events. They also man the ships that we have that do our ocean going measurements and also Great Lakes measurements of what's happening with fisheries, but also what's happening in the ocean. And then we also have the Office of Oceanic and Atmospheric Research. So it's a strong research arm that is focused on research of all of the work that we need to be able to go into operations across all of NOAA. That's actually where I spent the majority of my career, was in oceanic and atmospheric research at the Geophysical Fluid Dynamics Laboratory, which is where climate models came from. And we also have the National Environmental Satellite Data and Information Service, which is where our operational weather satellites lie. And also all of the data collected at NOAA is housed through various parts of NESIS for short, including our National Center for Environmental Information, which is where a lot of people go to get our observations of long records of what is happening in weather and climate and different measures. Most people are aware of the monthly reports that they put out on temperature that says, in context, what is temperature over the last month and how does that contextualize over our 175-year record?
To be needing to be experts in, from what I'm hearing, everything from space technologies to deep ocean technologies to weather technologies clearly requires a significant breadth of expertise. And I'm guessing quite a bit of cross collaboration with many other government agencies and departments as well.
Absolutely. And we didn't even get into space weather. We also have the Department of Space Commerce sits within NOAA and has situational awareness of where all the satellites and the debris and information is over space. And within the National Weather Service, we also actually have a space weather forecast office, which is forecasting space weather. So weather that's coming off of the sun, which then affects magnetic fields, which then create drag on satellites, but also affects the grid because it creates pulses in electricity, which can be problematic for the grid. It can be problematic also for GPS systems. So we have weather from the sun all the way down to what is happening at the bottom of the seafloor, mapping it, and where are the fish at the bottom there. And so it requires all this science, but I am very fortunate that we have amazing scientists across the agency that are very collaborative, and they flow through me through our science council and give me advice on anything I need, as I need to synthesize all the science of the agency. And our mission is science first, then service. So we're supposed to provide that science to other people and advice. So it's across the federal government, it's the public, it's whatever stakeholders, decision makers that need it. And the last is stewardship. So with the ocean, we are stewards of the ocean, making sure that we have a healthy ocean for years to come and generations to come.
On that last piece, does NOAA actually manage natural resources? Do you have direct areas of land or programs that are affecting the physical world that you are responsible for?
The resources being fisheries. Most people, when they hear fisheries, they also just think fin fish, the ones that fins, but it also includes crustaceans. It includes understanding what's happening with algae, understanding mammals, turtles. And it's not just the ocean, it's also the Great Lakes. I always make that point of Great Lakes. I'm originally from the Great Lakes region, and most people, when they think of NOAA, they just think of ocean, but we're including Great Lakes is also under our purview.
And in your role as the chief scientist, you said you're responsible for coordinating the activities across these scientists and understanding the outputs, I would assume being the conduit of that information to the rest of the federal government and the populace at large, and maybe bidirectionally back the other way. Is that how I should interpret your role?
Yeah, I have science and program direction for the agency, and I put out an annual report on what is our strategic research guidance memorandum of like important parts that we need to communicate of the research and the funding that we need through the budget process every year. And it highlights key areas of inquiry, both the long-term inquiry that we've been doing for decades, but also where the emerging scientific areas that we need to move into. I also put out an annual report of our science report, which is an annual report of the science of the agency, a snapshot of what happened in the last year. But then it's also giving the scientific advice when anyone needs it across federal government, when they need access to our science, need us to advise from our science, from our agency on different activities. I manage all of that. And then also, I'm very media facing, talk to the media about the research, about the science. We also actually have a lot of work with the private sector and understanding how we work with the private sector, especially being under Department of Commerce. But because of the value of the data and information, there's need for that and making sure that there's access to that, there's equitable access to it, and then also forming key public-private partnerships in areas where we really need innovation.
What's something that most people probably don't know or appreciate about the work of scientists in the federal government?
I don't think most people are aware of how passionate the scientists are in the federal government and how they are driven by the mission of our agency in being able to do the science that they need to create and support, and desire to have that inquiry, that discovery, and be able to advance the science. We just have such a passionate and hardworking workforce in that area. And they're really driven by making sure that they can provide the public with the information they need, no matter what.
How do scientists decide what should be worked on? What's the path for a given problem to get appropriate scientific attention?
It depends on what level of a scientist you are. So the junior scientists are coming in and they're working with people more senior that are setting certain areas of research agenda. And depending on where they are and where the funding type is, they either have a very specific project or they're doing inquiry to try and advance understanding in a broad area. We are setting those research agendas by our mission. Part of it also comes from appropriations to do certain things. For NOAA, our science is also geared towards making the science operational. So providing operational weather forecasts or information in the ocean, or being able to advance our modeling, our forecasts, our predictions, our projections, which means being able to know what's going to happen in the next minutes, hours, all the way out to decades and centuries. Being able to advance all of that and pushing forward on the science to be able to do that. And so depending on where they are, it can either be a very specific project towards advancing those problems, or there can be broader areas with more flexibility, particularly for the really hard problems with more uncertainty. There's a lot more exploration of the problems that need to take place. But fundamentally, our work is around weather, climate, ocean, fisheries.
The congressional appropriation was an interesting part because the way I understand it, Congress approves the budget and decides, hey, this thing is going to get funding, or this thing that used to have funding isn't going to have it anymore. To some extent, that also helps drive the agenda, as does, in many cases, getting the right people appointed into roles. And if you end up with people not appointed into certain roles, even if there's funding for something, there may be no one to actually direct the work to do that thing. Or it feels like those are somewhat unspoken also forces that help direct how work gets done inside an agency like NOAA. Am I thinking about that the right way?
The political leadership shapes some of it and can shape some of it, but vast majority of the scientists in the workforce are career employees that are part of the federal government. Much of the science that we also do, we don't see the results of that science for months, years, even decades for some of the work that we do, particularly on the really hard problems that we develop. For certain areas, there's a steadiness that occurs that you can't change that really quickly. That is part of the importance of some of the science that takes place at the federal laboratories that we have across many different agencies is that sometimes the scientific inquiry, particularly for really tough problems that we need to solve, takes a really long time.
Shifting gears a little bit, looking at your own background, you've had some work that you have done that has happened that has been very timely in terms of what you were working on when you were working on it. One, as I understood it, very early in your career, you were working on a bond program that ultimately ended up getting impacted by Hurricane Katrina. And then two, you spent a lot of your PhD time working on snowpack in the West, right as the West was entering into this massive drought period. Share with us a little bit about, I don't know if you were anticipating problems well, or if you were, to some extent, you can't be lucky by these horrible tragedies, but you had some things that lined up in terms of the work you were doing that ended up being very timely in terms of the importance of it. In retrospect, how do you view those times in your life?
Part of it is you do some science and you are interested in a problem, but then the world is changing around you and requires the science. And so it changes the science, but it also changes what you focus on. I finished my undergraduate in mathematics, which was theoretical mathematics at Princeton University, but I also got a certificate in finance and I was exploring applied mathematics. I went to Princeton thinking I wanted to be a theoretical mathematician. And then once I did theoretical math, I realized I didn't want to do that. And so I sometimes joke that I overcorrected towards finance and climate science, really real world problems of math. So I did some research on hurricanes and hurricane formation and catastrophe risk. That combination, I was fascinated by what the future of climate change meant and how it could impact financial markets.
This was before or after Al Gore, Inconvenient Truth, popular awareness of climate change?
Before, not many people are aware. So our geophysical fluid dynamics laboratory is actually on Princeton's campus. It was placed there because of the early development of computers, of computing from Johann von Neumann and the Institute of Advanced Study at Princeton. It was seen as one of the areas for computational mathematics to take place, was development of weather models, development of climate models. So the laboratory was there, and some of the theoretical mathematicians were like, well, if you like this applied stuff, this is super mathy. You should learn how to model weather and climate. If you want to do a real world problem, why not study the Earth? And so I started to study that information and learn about climate change from the leaders in understanding climate change. Suki Manabe was the one who developed the first model. He won the Nobel Prize actually recently for the development of the first model. So I was learning from him and other people that were huge in the field of climate change and understanding climate and understanding what was emerging and what was happening. And so I'm learning science from them at the same time that I'm taking finance courses at Princeton and learning about financial markets and learning about how one thinks about the economy and the macroeconomy. And so I'm learning about climate change and how it's going to completely change the world at the same time that I'm learning about what the current economy looks like and how it's structured and how financial markets are made, and also taking classes with experts on what happened with the Argentinian debt crisis, which is also happening, and how emerging markets respond to different shocks. And so I'm looking at climate, I'm looking at finance. I'm like, these two are together and they're going to be together, particularly if this climate thing explodes in the way that the scientist was explaining to me. And so I wanted to have a career in climate finance because I thought that those were two interesting problems. And the only way they intersected was financial institutions. So then I went and I worked at Goldman Sachs in financial institutions and was able to work on catastrophe modeling and trying to work on one of those bonds, having discussions about how I thought hurricanes were affected by climate change and wasn't in their model at the same time that then Katrina came through in New Orleans, really showed me that the financial markets were not thinking about climate change in the way that they needed to. And I was told by my boss, why are you focused on this? You're a finance person. And it really drove me to go get my PhD back in climate because I realized I wanted to spend the rest of my career being a climate person that could inform these things, not being a finance person.
Frequent listeners of the pod will know that we just had Kim Stanley Robinson, the sci-fi writer and author of Ministry for the Future, on the show. I would argue in that book, he makes the case that our political economy isn't set up today to solve these big problems of climate change, and that ultimately you have to change the money to get the world to make the change it needs to make. I'm totally spoiler alerting the book, but that's kind of what the book is about. And I'm curious, as you've worked at the intersection of climate change and finance, do you believe that finance drives the right outcomes or finance reacts to outcomes that are happening?
I think both.
The world's not as simplistic as we would like, is it?
There's so much nuance in it. And part of the reason I studied snowpack and water in the American West was I saw water as a critical component of society. And so I thought climate change, as it affects water, will be very tangible for people to be able to respond. And water is also an area where it's almost free in most parts of the US in the way that utilities operate and water has been structured, and also the rights historically. And so it's a fundamental market issue too that might transform or change in ways that we don't yet fully know as we deal with water crises. And so finance is one part of society that was built on a climate that no longer exists. As the climate evolves and as people see the changes and experience the changes, finance and other parts of society are going to transform in response to it. And what I often say about climate science as well is that it gives us an understanding of what the future holds in a way that no other forecasting does. It's based on physics. There is uncertainty, but we have a very good idea of what's going to happen in the coming months, years, decades. So we can take that information and adapt it to understand what do we need to do now in various parts of society, finance being one. It gives us this crystal ball that we need to take.
Such a good way to frame the problem, that the world was built on the assumption of a stable climate, and the climate is no longer stable, and thus the assumption that the world was built on are no longer valid. So what does that mean for everything we know? It's all likely changing around us, which is scary, but also creates opportunity for people depending on how you try to approach the problem. I think on that note, we know there's opportunity today to help the world with that transition, to help move to a clean energy future, to help move toward technologies that the world is hungry for that aren't going to further exacerbate the problem. On the flip side, what do you think the world will do over the coming decades around increasing resiliency in the face of an increasingly unstable planet?
All sectors of society need to respond to the climate challenges that they're facing, and adaptation to build resiliency will be different in each one based on their needs. For example, one that I am working on as chief scientist is we are working with the American Society of Civil Engineers to ensure that they have the science that they need to inform how they can potentially write building codes. So historically, building codes are based on historic data. We are gatekeepers of that historic data and put out the information every year. And then they've used it and adapted it to understand what the risks are in the past. That was under the static assumption that if you just looked in the past, you know what's going to happen in the future. If you go around the country and you talk to people that have that data, particularly when I talk to emergency managers or I talk to mayors, they will rattle off the statistics of how they're seeing things they've never seen before. Or in Louisiana, people are like, the worst rainfall events and worst flooding we've had, the 7 worst are in the last 10 years in our entire record. What does that mean? And how do we respond to that? For the built environment that responds to some of this information, there needs to be guidelines of how one builds for the future if you want to be able to build infrastructure that can either be built to last years and decades into the future, or even for the finance people in your group. I also think about efficient investment towards also retrofitting. So there is some uncertainty of what path we're on and how emissions change in the future. So you can also build for the next 2 decades with the expectation that you might need to invest again to be able to retrofit for further resilience. And so thinking in these new ways about how to build and how the world is changing is just fundamental to changing how engineers think and how they create their standards by which they build so that they don't have damages.
At MCJ, I work with a lot of early stage startups. And one of the things we always try to help startups do is understand what are your existing validated assumptions? What are the things you think you know about your business and you have data that says, yes, in fact, this is true? Because those are the things that fundamentally you should be marching toward and building on top of. What I'm hearing you say is there's a whole exercise to be done to go around in the bigger world around us and say, what are the things that we thought were validated that actually are no longer validated? And how do we find that information? What is the skill set needed to go poke those holes and shine the light for people on those areas? That is a very specific, unique effort and a specific skill set to be able to know how to ask the right questions.
We're starting to talk about those people as the climate translators, the people that can translate the climate information into actionable direction that any sector or person needs to use. I would say the very sophisticated scientist or technocratic person will say, okay, you just need the data of NOAA or the data coming out of the Intergovernmental Panel on Climate Change as information. You just need to take that data and put it in a report, and then anyone can use it. But you can't just put the data out there and hope that people are going to find it and use it and apply it. One of the things that we've been working on the last few years is making data accessible in different ways to different users. And so thinking about our user communities, we have the climate resiliency toolkit. We can go on and download climate information, but also there's case studies of how people have used climate information to build adaptation. We now have heat.gov, which NOAA led along with CDC around what is heat, your risk right now, what's the forecast, what's the seasonal outlook, but also what is the expectations of heat long term. And then it also has those adaptation plans of who is most exposed to heat, how do people respond, how do urban planners respond to it, how do buildings respond to it, how should your community manager think through cooling centers or plans to get elderly people that are isolated to a cooling center? How do you get the word out and do that? Depending on the need and the people in the audience, we have various different ways that we are trying to reach them. And some of them traditionally is putting the data out on these websites, but then there's this whole stakeholder engagement that needs to take place to be able to do that as well. And NOAA, we are structured to be able to do that. We're in the states and all the territories. We have our climate centers, CAPRISA centers that are across the nation that are supposed to be making sure that they're getting access to NOAA data information for their decisions. We also convene and do training with every state has its own climatologists. So there are state climatologists that are out there that are helpful to give support. For the funding that we give, particularly around coastal resilience, around conservation restoration, increasingly, as we put government grants out, and we saw this with our funding from BIL and IRA funding, we also provide technical assistance. So we have all those places that people can go on a website that they can find the data, but that often isn't enough. They also need technical assistance. So we also have people that are there to help through how do you do the calculations that are needed and how do you create your technical plan, and then also giving that support for those types of plans to do that work.
I want to come back to the funding for sure. I have some questions on that. Digging into, you use the phrase, the stakeholders that we work with, the stakeholders that your scientists engage with in the private sector and outside of NOAA. I'm assuming these stakeholders are often risk managers at big companies. They are architects. They are city planners in the government, folks like that that are trying to understand the future of a decision they're making today, what it might mean 20 years from now, what's the world going to look like. Are those interactions happening a lot? When they're building something, they're thinking that far ahead. I always hear one of the magical things about Disneyland is when you build a ride, you have to plan that it needs to continue to work for 50 years. And I'm hearing this same sentiment from you that NOAA can be a resource to help folks ensure the future viability of projects that they're doing today.
Yes. And by stakeholder, really, that's anyone who pays taxes in the US is getting our data and information. And those engagements that we have with all the different people, with corporates, but communities, states, regional entities, community organizers, architects, engineers, those are happening through various channels. We have all these different channels of which we distribute our information and do those engagements. Something that I also haven't mentioned yet that increasingly is becoming important, and I'm saying that as I'm actually looking out over the bay. I'm in Miami right now for work. In the coastal resilience space and what's happening along the coast and the ocean, we also have something called Sea Grant. You've probably heard of land-grant universities. Sea grant is within NOAA and it is funding for coastal regions to do the research, to do the engagement, to then also be able to pull together the projects that build resilience adaptation. And that is on our salty coast, but also along the Great Lakes. And our different sea grant offices deal with the problems in their states. Some of them are really focused on sea level rise and erosion. They also have aquaculture, so how you grow fish or how you grow shrimp or algae. They also have projects around sea level rise, around ports, anything that interacts with the ocean. The Sea Grant is able to have federal funds, but then also brings together the state, the local governments, the universities towards doing the research, but then also doing the actions around things along the coast.
Let me unpack a little bit more on some of the funding that NOAA provides, both today and potentially in the future. You just talked about the Sea Grant concept. In addition to being an information source, are there other forms of actual funding programs that people should be aware of that NOAA does provide to help with resiliency, to help with reinforcement of our existing communities and fisheries and the like?
So under the BIL and IRA funding, we received roughly $6 billion from those two pieces of legislation. And some of it is going towards coastal resilience. And so for some of the funding, and we've already put some of this out the door, some of the funding has been towards either restoration of a wetland to reduce the flooding that is occurring and putting in seagrass. But also, we've even helped move communities in Alaska that are facing erosion and sea level rise and storms and need to move back from the coast and how that happens. But a lot of people are starting to think about coastal resilience. They also think that sea level rise is something in the future. In Alaska, it's happening at a faster rate. We're seeing the erosion. We're seeing communities that need to move. And it's a different challenge in Alaska than it is in an urban center in the lower 48, because in Alaska, often there isn't the development inland. So you can move those communities more easily. The challenges in the coastal zones and urban environments is figuring out what to do now when you have populations and you have development. How do you build that resilience in those places? And some regions, the action they're taking is creating or augmenting natural reefs. So we have a whole program that I just visited here in Miami around coral reef restoration. And so we actually know how to grow coral reefs, restore them afterwards. And they're really important for storm and wave action to reduce the erosion that takes place. There will be additional grants around coastal resilience, around climate ready fisheries. We have various programs for resilience for using our data and information. And then there's also a lot of competitive grants that we do for fundamental scientific research, but increasingly it's also on that translation of the science. So engineers and insurers and reinsurers are applying for that funding, often with either federal scientists or even academic scientists, around trying to understand what the future holds and how to translate climate information into various climate risk information or weather extreme information. We also fund grants around how do you effectively communicate risk, either in forecasts or long-term risks, so that people take that information and act.
You said BIL, for folks who maybe didn't pick up on that acronym. That's bipartisan infrastructure law. And funding, I don't know if the sea level relocation funding was part of bipartisan infrastructure law or part of Inflation Reduction Act. Maybe you could clarify that if you know. But thinking of resilience as infrastructure is a really interesting concept to me.
Fundamentally, the built environment was built for what expectations of the previous climate were. And so to ensure that it lasts into the future, you either need retrofitting or new rebuilding or potentially changing. Infrastructure, fundamentally, built environment needs to change in response to that.
Hey everyone, I'm Yin, a partner at MCJ Collective, here to take a quick minute to tell you about our MCJ membership community, which was born out of a collective thirst for peer-to-peer learning and doing that goes beyond just listening to the podcast. We started in 2019 and have grown to thousands of members globally. Each week, we're inspired by people who join with different backgrounds and points of view. What we all share is a deep curiosity to learn and a bias to action around ways to accelerate solutions to climate change. Some awesome initiatives have come out of the community. A number of founding teams have met, Several nonprofits have been established, and a bunch of hiring has been done. Many early-stage investments have been made, as well as ongoing events and programming, like monthly Women in Climate meetups, idea jam sessions for early-stage founders, climate book club, art workshops, and more. Whether you've been in the climate space for a while or just embarking on your journey, having a community to support you is important. If you want to learn more, head over to mcjcollective.com and click on the Members tab at the top. Thanks, and enjoy the rest of the show.
I think of often the DOE, the Department of Energy, as being the vanguard for defining how our energy systems should change, what the transition should look like, where the world should go from an energy perspective in order to reduce emissions of our energy systems and ultimately, eventually migrate society off of fossil fuels, which is what most scientists say is what needs to happen to slow down and ultimately stop the effects of climate change. I'm picking up from you that NOAA has a big role to play. Okay, so that's great. That's like offense. What DOE is doing, how do we move forward from an offense perspective and change the direction we're going? I'm hearing that NOAA is almost very involved in the defense side of things, which is the world is going to change no matter how good of a job we do in transition. We're already into change now. And what does the world need to know about that change? And what are the things the world should be doing to get ready for it or to act on it? Or can NOAA even help them make change happen? It's an interesting aha that I had that I don't know that I had coming into this conversation.
People for a very long time thought too that if we mitigate and we reduce emissions and we clean the grid, that this climate change problem wasn't going to be something that we would all have to experience. But we are seeing changes in the probabilities and magnitudes of events and of different parts of climate all around the world. No place is left untouched. Climate change is already in the here and now where we are experiencing it, and we need to respond. As long as emissions continue to increase and collect in the atmosphere, the manifestations of climate change will continue. The science of NOAA is understanding what those manifestations are into the future, but our main focus is on the physical, the biological, the chemical, the hard science of what is to come. And then those intersections of how those then affect society, that then shows us what we need to do to adapt, to build resilience. And so with our social behavioral economic scientists across NOAA, we understand those translations of some of the ways that people either will respond, or we translate it also into financial impacts. I didn't mention this, we manage the $1 billion disaster program data set. So since 1980, we quantified $1 billion disasters of at least $1 billion of damage at CPI adjusted. And we count the number of those disasters and the total value. And we also classify what types of events they are. Is it a hurricane? Is it a flood? Is it a drought, severe storm, like those with hail and tornadoes? So we quantify those in time. And since we started taking those measurements, we saw $1 billion disaster roughly every 2.5 months. And now we're getting one every roughly 2.5 weeks. More are happening. They're extreme weather and climate events, and they're happening because there's vulnerabilities in society. If we adapt, we can actually bend that curve and not see more of those types of events, not see more damages. But if we expect that with climate change that it won't affect us when our buildings and our agriculture and everything was built for a climate that doesn't exist anymore, we will see more damages. And so the information that we have of knowing what the future looks like can inform all the different decisions and investment and activities to be able to avoid that. And it can sometimes feel squishy when I talk about that. So like one concrete example is for agriculture, for certain types of wheat. Certain types of wheat need less water, but also are hardier in heat. And just changing those seeds is really important. So we work with USDA. We also work with State Department and USAID on understanding what does it look like now and what does it look like in the future? And then how does that inform your programs as you're trying to inform agriculture in the US and abroad of what needs to be planted to deal with that?
Climate science has models that show here's what temperature changes are going to be at various emission levels, or in terms of slowing down emissions or lack thereof. Here's what the temperature implications are going to be, and at each of these temperature bands, here's what this might mean in terms of effects on the world. With your erstwhile finance hat on, does NOAA do the work to then understand what are the financial implications of those things? Or does that go to someone else in the government to manage?
We do it in the case of fisheries in particular, because we are supposed to manage fisheries. And we also put out an annual report on the state of the economic health of fisheries. And we also work with our partners in commerce around quantifying what is the marine economy and how is the marine economy doing and how do you forecast that into the future. So there's some knowledge in that. We are fundamentally doing the science, making the projections, and that information is for understanding all the financial impacts. And you're starting to get into what is the risk to other parts of government and what are the exposures. With that,
And even like what percentage of all of this is going to get funded by government dollars relative to private dollars being impacted? Those are potentially, I presume, giant numbers. I don't know where to find those things.
well, it's hard to find those things because that area of economics is really only growing right now. Actually, at the beginning of the Biden administration, I was a bench scientist at NOAA and I was working at NOAA, and I was able to advise on the executive order that the president put out on climate finance risk. That came out in May of 2021. Then after that, I went to JP Morgan and was there for some time before coming back as chief scientist. And that executive order actually launched a need to start quantifying what are the risks and exposures of climate change, because we don't have the processes to do that in government. And also academically, there's some research in the space, but it's not robust enough to do the budgeting, the understanding of the future in the way that people are really comfortable in with anything else that they're doing for budget forecasting or understanding the effects. And so one of the things that has been launched as a result has been this roundtable at the National Academy of Sciences that I sit on as an ex officio member, but also people from Treasury and Council of Economic Advisors, also economists from academia, experts in various fields of economics and science are all sitting on this and are talking about how do you develop the research and the work that is needed to do these types of forecasts and understand what those future damages are in the way that we do it as routinely for everything else. We're also at this special moment in time where people are realizing that they need to go quickly to develop the tools and the science to make those types of financial decisions. That work has not happened at the level that it needs to, or the level that we would like that we have for everything else. And so we're still in the stage where there's a lot of uncertainty around that. And that is where fundamental research needs to advance. But directionally, we do have information on certain issues like sea level rise and the cost of sea level rise affecting coastal regions. We know what the sea level rise is going to be, roughly a foot in most of the US by 2050, and parts of the Gulf Coast states, it'll be 1.5 feet. And so we know what has exposure to that right now. And so unless there's adaptation around those activities in the coastal zones or trying to deal with that, those assets that are along the coast will be lost.
All right, we're going to come back to that and implications in a few other areas as well. I just want to underscore something that I heard you say and imply, which is we don't have all the answers yet on the size of the resilience response that needs to happen because we haven't done all the work yet. This is all still new and it's changing like everything else. And I don't know if I take comfort in that or am concerned by that, but it's interesting to hear that this is still new. We are still trying to figure it out. It's a good reminder to me that for, 20 or 30 years, scientists were screaming into the wind that climate change was going to happen. Finally, people started listening. And then for maybe the last 10 or 15, it's been a concerted effort, maybe not as fast as everyone would like, but to put plans in place to transition our energy systems, to move toward renewables, to electrify everything. And that has momentum now. It's building, it's building, it's building. And now it's time to turn our attention to, but it's not going to happen fast enough. And the world is going to change and continue to change. And what does that set a problem? And gosh, if you are a young postdoc right now, it feels like you've got so much important work to try to map out in front of you. It just feels potentially like a scary time, but a very important time to be a scientist and help the world get their arms around all of these changes that are coming.
It's an incredible time for the scientists that are coming up. they're shifting towards being solutions focused. And talking to the students that are coming through, it's different than when I was entering grad school. When I entered grad school, I was like, I want to figure out how to do climate finance. What are you talking about? And now, even the physical scientists, the one that want to do more theoretical work, they're starting to think in this area of how do we create the data we need for the changes that we're seeing and the challenges and questions that we need to ask of society. There's more interdisciplinary work than I've ever seen before. There's also been a shift recently. There's many climate programs that are focused on, as you said, like there's a lot of focus on the energy side and mitigation, and that's really important. But there's also growing interest and understanding that we need to figure out how to adapt and how to build resilience. And so there are new programs setting up around that. Those intersections, they're with the built environment. They're also with health, which is an emerging issue of all the different ways that you need to be resilient. And in some ways, resilience and adaptation, measuring it is also a little bit harder because in everything with mitigation, you can boil it down to some sort of equivalency of carbon dioxide. Whereas resilience and adaptation, those metrics depend on the thing that you're looking at or the piece of society, the piece of the economy, the sector that you're in. And so it's a little bit harder, I think, for people to understand what that means. And for investors, I think it's harder because you want like one thing and it's confusing with there's many things. The challenge of this is that it's affecting everything and everyone is going to need to push forward on it. Putting back to the young students and the scientists, they're pushing on this in all different fields and all different areas and trying to create those interdisciplinary programs with that thinking because they have the thing that interests them and they're seeing it as a piece of the climate solution. And so I also say that to anyone working even outside of science, that every single job can be a climate job of some sort because everything that you do will be impacted in some way. And so if you start thinking in that way of how the world is changing, you can then understand how your business practices need to be adapted.
One could argue that of all the money we as a society will need to spend on the energy transition, the amount of money that we as a society will need to spend on battening down the hatches is probably an order of magnitude greater.
The hard part is the amount that we need to spend on adaptation depends on how much we spend on mitigation, because that puts us on different paths. Historically, there's only been 5 to 10% of most global finance, this is public and private, has been spent on adaptation. Vast majority has been on mitigation, vast majority for the energy systems. We see that it needs to at least double. And depending on which pathway and what happens in the future in terms of emissions, that number could go up or it could go down. And it all depends on where we are.
When it comes to funding, when I think of resiliency and adaptation, I think of like big infrastructure projects being driven by huge global engineering firms. I spend my day working in the startup world. I'm curious what you're seeing out there in terms of both opportunities for startup innovation as well as potential funding sources for startups outside of venture capital dollars, like government programs and the like, in adaptation and resiliency in particular.
A lot of the science and a lot of the research that we're doing relates to adaptation and resiliency, and the use of data and information or development of new data and information can be applied towards adaptation and resiliency. And we fund at the very early stage through our small business innovation research grants, we give those grants to the startups that haven't received any money. And so that is first about the business plan and building out the concept, but then it's also creating that proof of concept to be able to move forward so then you can get that angel investing. You may not be aware that every single science agency actually has these SBIR programs that are supposed to fund small businesses, be able to launch them.
I didn't. I think of SBIR as mostly coming out of DoD. I don't know that I knew that NOAA and other agencies also have SBIR channels. That's super interesting info for me to go spend some time on.
Every science agency has an SBIR program, and I welcome you to go look at ours. And NOAA, traditionally, it's related to all of our different science areas, or also where we need to see innovation in the private sector to be able to help co-innovate in critical areas to create new data or new measurements that we might also use ourselves. A lot of them that have been successful that people have been seen has been around use of satellite information or new sensor technologies in the ocean. And increasingly with aquaculture and the advancements of aquaculture, that sensor technology is really important. We have also funded Ocean Accelerator program. And we actually released the first tranche of the grants that we funded for that of accelerators around the country. And the idea of that too is moving beyond just that early stage concept to being able to be in the next stage for growth and for more development so that those companies can then grow, really finalize the technologies and start scaling it, but then also create that community so that they get the business advice that they need, the connections that they can then also find their customers, and also with support from academia or with the cities or the regions that are involved in them, then grow to that next stage so they can get venture capital. So we're trying to fund at the different stages of those companies between our SBIR program and these ocean accelerators. And I would say that ocean accelerators have taken off in Canada and the United States. We are seeing more and more interest in them as well and demand for them. And so we've been funding them as well.
We've seen, particularly in the United States, unfortunately, a lot about climate change be politicized, a lot about the energy transition be politicized. I understand in some cases why. People's livelihood is in oil and gas. People's family grew up in those businesses. There are personal reasons why people feel the way they feel about different things and policies, and is what it is, even if the science says there's a very clear path that needs to happen. Resiliency and adaptation feels intuitively like it should be a bipartisan issue. People want their neighborhoods to be safe. People want their communities to function the way they're used to them functioning. People don't want natural disasters. And yet I don't hear much being spoken about around these topics. And I'm curious why that is, or if you think it's just a matter of time.
I think it's just a matter of time. I think we talk in different communities because that's all I speak about all day. The climate mayors were here in Miami this past week, and I was talking to many of them across the country, and many of them are even saying what you're saying. This wasn't on my radar until I saw a bunch of floods, or this wasn't on my radar until we'd experienced the worst heat wave we've ever experienced. And now I'm trying to figure out what that means and what I do. As people are affected by extreme weather events, extreme climate events, there's this heightened awareness right afterwards. They want to build resilience. They're like, how do I make sure this doesn't happen again? And in that awareness is also when there's also an influx of dollars to be able to deal with the problem, is they want to know, how do I build so if this exact event happens, doesn't cause deaths or doesn't cause damages? And increasingly they're asking, okay, we've never had this event before. What is the likelihood of events in the future? How are those changing? Because whatever we invest right now, I want to make sure lasts for 5 years or 10 years or whatever time horizon they're available to. And then it adjusts based on the amount of money that they have. But they're increasingly post disaster asking those types of questions. No one wants to see bad events happen. They don't want their economy to suffer, their livelihoods of the people around them to suffer. And so they want to be able to live. They want to be able to continue their activities. And so post events is when people are most aware of it and are trying to figure out what to do. And you will just see more and more events around the world.
I want to make sure we do give some airtime to some of the science that is causing some of these events. I think it's really important for people to understand at least the high level of some of the changes that are happening. People who listen to this pod presumably understand the greenhouse effect and why carbon emissions in the atmosphere cause the world to be warmer or to change temperatures. But maybe let's click a level deeper on what is happening with our atmospheric circulation, what is happening with our ocean currents and our ocean patterns. There was big news that came out, I think, about a month ago about the Atlantic Meridional Overturning Circulation, the AMOC. Maybe give people the latest science of what is happening in the world's circulatory system.
So the National Center for Environmental Information in NOAA puts out a report monthly that gives you a state of the climate of the last month or the last several months or the last year. And then it contextualizes it within our long record. So for this past month, February, and the months preceding, we saw that every single month was the warmest on record. And we had that for 9 months straight. And that is due to both climate change, creating this warmer environment and increasing it, but it's also due to the fact that we also had an El Nino. So the El Nino is when it's really, really warm in the Eastern Pacific. All this heat that's in the ocean that gets stored suddenly comes out of the ocean in that location. that goes in the atmosphere. So we have had this long warming trend, but then on top of it, an El Nino increases global temperatures by about zero point 0.1 degrees Celsius. So this pushed us over the edge where we broke all these atmosphere temperature records. It also led to us breaking ocean temperature records. Almost roughly 40% of the ocean was also in a marine heat wave. So it wasn't just a heat wave in the atmosphere that we were seeing global temperatures were high. We were also seeing it actually in the ocean. And combination of things in the ocean is the El Nino, it's global warming. There are a bunch of theories also that it could be changes in aerosols, that there was the volcanic event that also could impact it. There's going to be a ton of research to really understand all the reasons we saw such a warm year in 2023 and in recent months in the atmosphere and in the ocean. These have manifestations as coral reef bleaching. We just went out and we looked at the coral reefs in the Florida Keys, and there's only 20% of stag corals in them. So when it gets really hot, the corals bleach. We also, to your point about the Atlantic meridional overturning circulation, have had a bunch of research papers have come out recently on that. And they're using a combination of observations and models to say, what is the state of that now and what do we expect in the future? And the observational papers are starting to say that you're seeing a slowdown in that circulation pattern in the ocean. And then the models are trying to say, would it stop or reverse at some point? And so what that is it's how water circulates in the Atlantic, where you then have the water at the surface goes very deep into the ocean, so it sinks down. That drives how the water moves around all the Atlantic Ocean, but it also pulls heat and energy into the northern hemisphere, so it makes Europe a lot warmer. It also brings in, because since it's warmer in those top ocean atmosphere, it also brings moisture to Europe. And so if that were to slow down, we would see it become much drier and colder in Europe, relatively, which is problematic because they're worried if there was less water, they would have problems with agriculture. It also automatically changes sea level rise on the East Coast. There's a lot of research around this. There's also some sensationalization that I see as people see some of the media on it. We don't know exactly how that is going to change or when, but we do have an idea that directionally climate change is making it slow down.
Going the other side of the US with the West Coast, we just emerged from this mega drought. And this year, the West Coast has been inundated with snow and rain. Is that a good thing? Is that a bad thing? How should we interpret that?
I think a lot of people have forgotten living on the West Coast, living in the worst multi-decade drought in over 1,000 years. They've forgotten that California has these boom bust cycles of wet and drought historically. California in particular gets the vast majority of its precipitation in only a couple of days in the year from these things called atmospheric rivers that bring moisture from the tropics all the way up to California. Historically, we see these years, and often the way that multi-year, multi-decade droughts break is by a season like this. The water is important because it's refilling the reservoirs. All the mass amounts of snow will lead to that melting later in the season, which will hopefully reduce the fire season this upcoming summer. We need that water. We need that snow. We need that desperately. But with climate change, there's an expectation that it gets drier on average in the American West. So it's a reprieve, but it's expected to get drier on average. But just because it gets drier on average does not mean that you will not get years like this where you get storm after storm that brings the snow, that brings the rain. I call these things climate conundrums. When you hear the general climate change term, it makes you think that you're going to have one state, but actually the variability, particularly in those extreme years, can be counterintuitive to it. It creates a communication challenge for us, but also a preparation challenge for how to prepare and deal with that different type of climate than what we're used to.
And you mentioned you're from the Midwest and the Great Lakes are part of NOAA's purview. What are you seeing change around the Midwest?
For a long time, people thought that climate change was going to reduce lake levels. Lake levels did get reduced, but then they rebounded really rapidly in the last couple of years. And so there's a lot of work right now understanding what is the variability of lake levels in the Great Lakes. There is infrastructure and buildings along the lakeshore. And so the future of that really matters to those people. We also saw record lows for ice across the Great Lakes this past winter because the US had such a warm winter. Where are you based?
I'm in Los Angeles.
So you were dealing with all the water, whereas the Midwest was dealing with this really warm winter with people being bitten by mosquitoes in Minnesota in February. They usually should not be out for another few months or weeks. So it was warm, and it was warm due to climate change. It was warm due to El Nino, and then also warm due to the fact that this ice didn't form. There's a lot of research still to understand what is the future of ice. There's expectations the season for ice will be shorter. There's a lot of work to understand what is the variability of that going to be, particularly after we saw this extreme low of ice. There's going to be a lot of questions about what expectations are for that for the future. And then also, as a counterintuitive response, when there was less ice, there was more water that could evaporate, which then enhanced some of the storms that came across the Great Lakes, which dumped even more snow and lake effect snow in some places where people live. While it can be warmer, it can have these counterintuitive things where you then actually also get more snow when you do get a storm in some of those places.
If you had to extrapolate 30 years from now in the US, do you anticipate there are significant population centers today that won't be wholly viable for people to continue to live in? Or do you expect humanity to figure out how to enable existing societies to continue?
Humans are able to respond to our climate. We live in Antarctica. NOAA actually has had a station there for decades. We also have people that live in deserts. And so what will change is how we build for the different types of climates that we experience and how we need to retrofit what we have in existing buildings or infrastructure to deal with it. And with anything, people move around. And so people may move around to be in the climate that they like, or also following the services that are available and are adapted to what they want. That is a question for the anthropologists of what we will exactly see in the United States and around the world.
So, as we think about the planet changing around us, there are a lot of things we can do to harden infrastructure and help communities adapt. There are also some technologies out there that might be almost in the realm of science fiction that are seeking to directly intervene in our natural systems and change them, change how the ocean works, change the acidity of the ocean, change the solar reflectivity of our atmosphere. Surely NOAA has been asked to weigh in on the implications of these things or the viability of some of them. I'm curious which ones of any of these topics you've dug into.
Our job is to monitor the planet, but then also understand and project the future. On the topic of marine carbon dioxide removal, we actually put out last summer a report of a science strategy for marine carbon dioxide removal. What is the science that we need to do? And it was agnostic to technology and type, but it was laying out what is the science that needs to take place to understand it. We also, through a public-private partnership, we funded and we brought together various entities under NOAA. So we led the competition, but we brought together the Navy, we brought DOE, we brought NSF, we brought ClimeWorks together to all fund technologies for marine carbon dioxide removal. It was actually put underneath our ocean acidification program. So it's all the technologies to monitor, to measure, to create some modeling around it. But it's also fundamentally, how do you have a change in the pH? How do you reduce the effects of ocean acidification? And one of the technologies that I'm really excited about, if it works, as they do this research, is one around taking sewage treatment plants and doing alkalinity enhancement, and then having that water return to the ocean in a region where you also have aquaculture. Because we're starting to see with shells and crabs and shellfish and clams that you are starting to see the effects of ocean acidification and their ability to make their shells. And so if we can create a program where you have that alkalinity enhancement, potentially takes carbon out of the atmosphere, but also deals with that acidification problem, you then also solve an issue of shellfish. And when I talk to people in the development space about this, if that technology also works, that potentially is also a technology that you can apply for development around the world, where you need these infrastructure projects for water pollution and water quality. And then if you can actually implement that, you deal with the pollution problem, which is a major issue for coral reefs and coastal zones. But then you also deal with the aquaculture problems that we're starting to see with ocean acidification. And then on top of it, you might be able to enter the carbon markets and access the carbon markets, but also have the drawdown of carbon. I see it as a critical thing that we need to be studying and figuring out what we're going to do in this space and make sure that we have the impacts that we expect if these types of technologies are pursued.
We've had a few companies focusing on these types of solutions on the pod in the past for folks who want to go back into the archives and just learn about some of the methodologies. They may not be ones that you necessarily wholly endorse or not, but there are at least people thinking about these. In particular, there's a company called Planetary and there's a company called Vesta that folks can go back and listen in the archives and just hear about how these entrepreneurs are thinking about the science and the potential business opportunities in this space of ocean-based carbon dioxide removal.
So you can also picture it. We're monitoring the world's oceans. We have information around the world, but over 50% of the world's oceans is monitored by NOAA. The measurements are coming from NOAA. And one of the major measurements that we take around the world is through the Argo program, which are these floats that go along in the ocean and they follow the currents, but they take temperature and salinity, they sink down and then they come back to the surface. And so they take these profiles of the ocean of that information. So originally they were just temperature and salinity, and that's really important for us to do seasonal prediction because the ocean moves slowly, and so that affects the atmosphere, so it lets us know what's going to happen over many seasons. But increasingly they're called BGC Argo, biogeochemical Argo, and that can also have pH sensors, can also have different parts of biology. So we can also get a bigger picture also of ocean acidification information around the globe with these types of measurements. And so it's a fundamental important piece of knowing what's happening in the world's oceans, but potentially also underpinning any future markets around these space.
Moving from oceans to atmosphere, what about the reflectivity type of technologies that are out there? I assume you guys have spent time in that space as well.
It's very fitting you asked me about this, given the last guest on the podcast was Kim Stanley Robinson. NOAA actually already manages an Earth's radiation budget program, or as you said, reflectivity technology. The radiation budget represents the balance between incoming energy that comes into Earth from the sun and all of the outgoing energy. So this is the thermal energy, or that's the reflected from Earth. At the direction of Congress in 2020, we started a multi-year research initiative to investigate both the natural as well as the human activities that might alter the Earth's radiation budget, or ERB for short. This includes reflectivity of the stratosphere, so particles in the atmosphere 7 to 30 miles above the surface, as well as in the marine boundary layer, so closer to the Earth over the ocean where you have clouds forming. We recently flew flights into the stratosphere to measure its composition, to see what aerosols are already up there. This led to important discoveries made with these findings a few months ago. NOAA scientists estimated that about 10% of stratospheric sulfur acid particles in the stratosphere currently contain traces of metals from rockets and satellites thought to burn up in reentry in the atmosphere at the end of their useful life. In measuring the stratosphere to create a baseline understanding of its composition, we found particles that we didn't expect. We're now working on a report to Congress to create a blueprint for an overall science strategy for solar radiation modification. Again, just like with marine carbon dioxide removal, it is agnostic to the specific methodology. We pulled together our scientists and have sought input from other agencies on how to get a handle on understanding scientific questions related to solar radiation modification, to understand it and all of its potential impacts. I really need to stress that NOAA is neither for nor against solar reflectivity. Knowledge gaps exist that prevent informed decisions about the potential risks and benefits of these techniques, and we have a congressional mandate to understand the fundamental processes involved in solar radiation modification and its impacts on climate, the Earth system, and society. The strategy we're now working on will come out later this year. Also, knowing that solar radiation modification activities by academics and startups are increasing in the news, I also need to mention that the Weather Modification Reporting Act of 1972 requires that all non-federal weather modification activities be reported to the U.S. Secretary of Commerce at least 10 days before the commencement of such a project or activity. This requirement is actually delegated to NOAA. And while the Act requires submission of a report to NOAA of any proposed weather modification projects, there is no approval role for NOAA regarding carrying out these activities, i.e., NOAA is not a permitting agency for the activities. We're just receiving the reports and then we're making them public.
Where should a person like me go to find these papers as they emerge?
You can find these reports and information on NOAA's Science Council website, sciencecouncil.noaa.gov. We maintain all of our scientific reports there that are syntheses across the agency. So we have the Marine Carbon Dioxide Science Strategy that came out last summer. We have an annual Strategic Guidance Memorandum, which I already mentioned. We have our annual science report. We also create NOAA State of the Science fact sheets. They're scientific and technical and a little bit dry, but they go through a rigorous process to distill the knowledge of our 7,000 scientists down to the essence of what is the state of the science on specific topics. The future solar radiation modification report to Congress will also be found here if it's made public. All of our non-federal weather modification activities reported to NOAA are also available publicly on the NOAA Library website. Historically, these have been mainly cloud seeding efforts, for example, by ski resorts to extend the season. This website can be found by searching NOAA Weather Modification Project Reports.
Today, people look at the weather forecast to decide what they're going to wear, if they're going to take an umbrella in their car or whatever. I know certain people who are deciding where they want to move their families because of what they expect climate change to look like if they're going to make a long-term investment like buy a home. Do you think that becomes more the norm for people, that they build this long-term change planning into their own personal lives?
I think as people become more aware of what data is out there, they will respond to the data as it is available for what the future holds. I'll say that about 10 years ago, journalists started asking me, what is the ideal climate place to live? And I even wrote a paper on it, on what parts of the world have the best mild weather days. So, a day without too much rain. It's not too hot, not too cold. And we could map it around the world of where the good weather was. Those patterns are changing. And it all depends on people's preferences for what type of climate, but it also is all the opportunities that exist in society and in housing and all these other parts of society and economic opportunity, which may not match perfectly with climate. And so to be able to understand where people will be depends on all those other factors. And that's what makes adaptation and resilience so complex, is it is the combination of the science and what we expect in the future for our climate, but it also depends on what we have built around it to provide people the lives that they want.
I would guess many in the finance and insurance worlds are starting to make those bets now.
If the built environment is not resilient to extreme weather, extreme climate, it will change. Either the environment will change or the capital will change.
Sarah, this has been really, really informative. What more would you like to share? Any calls to action? Any areas that you want to make sure that listeners who are motivated by your remarks today know ways that they can lean in and help? What do you want to see more of in the world right now? Where would you ideally like to see more effort, more resource, more brain power going to work?
So first of all, I want to say, when I talk about the facts about the changes that we will see, I always worry that people are going to get very depressed listening to me. And I just want to say that we know what to expect in certain parts of the world due to climate change. And then we take that information and then we use it. That gives us the power to figure out what to do next. It allows for innovation. I think innovation is the most important thing that we need to do around adaptation and resilience. How do we take this information? How do we transform society? It needs to be where we are focusing many of our efforts.
Well, I appreciate your time today, and I learned a ton, and thank you for the work that you do.
And thank you very much for letting me tell the story of NOAA.
Thanks again for joining us on the My Climate Journey podcast.
At MCJ Collective, we're all about powering collective innovation for climate solutions by breaking down silos and unleashing problem-solving capacity.
If you'd like to learn more about MCJ Collective, visit us at mcjcollective.com. And if you have a guest suggestion, let us know that via Twitter at MCJPod.
For weekly climate op-eds, jobs, community events, and investment announcements from our MCJ venture funds, be sure to subscribe to our newsletter on our website.
Thanks, and see you next episode.